Hi, my name is Charles Winfield. This is Module 13 Project, Rocket Food Delivery, a full stack mobile food delivery application. This video is split into two parts. Part 1 is a live functional demonstration. Part 2 is an in-depth code walkthrough where I'll explain the internal logic, the specific variables and conditions used, and the reasoning behind each decision. This is the Rocket Delivery login page. The app opens on the login screen because there is no saved session. I'll demonstrate the validation first. Submitting with the empty field triggers a client-side check before any network call is made, and the error renders inline above the login button. Entering the wrong password sends the request to the API, which returns a 401, and that error message is extracted from the response and displayed in the same place. Now I'll log in with valid credentials. All right, now we're logged in. All the restaurants load from the API on Mount. Each card shows a restaurant image drawn from a local image library, the name, the price range, and star rating. The two drop downs, select with no filter applied. Select 4 stars, filters to restaurants rated at 4 and above. Combining that with the price filter further narrows the list. Clearing both results in the full list. So 4 stars and above, and then we do a price range. There's nothing there. And then we'll do 2 stars in that price range. 2 stars without the price range. 3 stars. And then we'll just do price ranges. And as you can see, all these do populate. All right. Next, menu and order. Tapping the card opens the restaurant's menu. Quantities all start at 0. The minus button is visually disabled at 0 and cannot go lower. The only way to change a quantity is the plus and minus buttons. There is no text input. The create order button stays grayed out and disabled until at least one item has a quantity above 0. Adding items enables it. Tapping it opens the confirmation modal. So we'll go ahead and add some items here to create an order. Tap the create order button. The modal opens. We have the items here listed, and then you can confirm the order. We've got a process and order, and then a thank you submission. The modal shows the order summary total, and tapping confirm order disables the button, which switches next to the processing order with a spinner. On success, the button appears with a green check mark with a success message. If the API call fails, a red cross icon appears with the error message. Confirm order comes back. All right. Then we also have the order history button here. Oops, I'm sorry. It's like right on top of that. All right, there's the order history, and this was the most recent order placed. If we tap on the magnifying glass, we get another modal pop up, and it shows the order. And it shows it as pending. And then we can go back to restaurants. All right. And that concludes the demonstration of the application. We'll go ahead and show the logout button to show that it goes back to the login screen. Before going into any specific logic, here's the structure. The client is a React Native TypeScript app using Expo Router for file-based navigation. Every file inside the app folder automatically becomes a route. The parentheses folders, often tabs, are route groups. They organize screens without adding the URL path. So the auth login, TSX, is the login screen, and the app tab's restaurant index, TSX, is the restaurant list. But the URL only shows login and restaurant, not the group names. The services folder contains the Axios instance, the auth context, and one file per API resource. The components folder contains all reusable AI pieces. That's here. Excuse me. And the server is a standard Spring Boot project. Controllers receive requests. Services contain the business logic. Models are JPA entities mapped to SQL tables. Authentication and context, variables, and state. The auth context is the most important file. Let me open it and walk through it precisely. At the top, 4 state variables are declared in the use state. Is signed in is a Boolean. False by default. Is loading is also a Boolean. True by default. And this is important. I'll explain why in a moment. Auth token holds a string or null. It starts as null because no token exists yet. Customer ID is the same string or null. When the component mounts, a use effect runs with an empty dependency array, meaning it runs exactly once inside async storage.getItem. And it's called for both token and the customer ID. Async storage is a key value store that persists on the device across app restarts. The keys are the strings, auth token, and customer ID. If both values come back null, set is signed in is called with true. This is how the app restores a previous session without asking the user to log in again. The reason is loading starts as true is to prevent the navigation guard from firing before this check finishes. If is loading, if is loading is started as false, the use effect in the root layout would immediately see is signed in as false and redirect to login. And even if there's a valid, even if there's a valid save token, starting is loading as true holds the app on the loading screen until async storage has been read. Then it sets to false regardless of outcome. The sign-in function takes 3 parameters. It takes email, token, and customer ID. It calls async storage set item for each key value pair, then updates all 4 state variables. The sign out function does the reverse. Remove item for both keys, then resets is signed in to false with auth token as null. And that is the authorization. So now we'll go into the root layout and the navigation. The root layout job is to enforce authentication. Inside root layout nav, a use effect has a dependency array containing is signed in and is loading. Make sure I'm on the right. Oh, that's not the right file. Okay, sorry, I was inside the wrong layout file. This is the correct one. So this is the root navigation. Root layout navigation guard. The root layout's job is to enforce authentication inside the root layout nav. A use effect has a dependency array containing is signed in and is loading. This means it reruns whenever either of those two values has changed. The very first line inside use effect is loading, or is not loading. The condition is the gate. If is loading is still true, meaning async storage hasn't finished reading yet, the entire block is skipped. Nothing happens. Once is loading becomes false, the condition passes. The condition passes, and we check is signed in. If is signed in is true, if is signed in is true, the router.replace is called with the restaurant route. If false, the router replace is called with the login route. Here. All right. The key method here is replace, not push. The difference is that push adds a new screen to the top of the navigation stack so the user can press back to return to the previous screen. Replace swaps the current screen entirely, removing it from the stack. This means after you log in, you cannot press back to get to the login screen. And after login, you cannot press back to get to the authenticator screens. While is loading is true, the component returns the activity indicator, a full screen spinner. This is the loading gate that prevents any flash of the wrong screen. All right, next we're going to go over the restaurant filtering, conditions, and operators. The restaurant list uses two separate state variables for the filters. It uses selected rating and selected price. Both are initialized to null. Null here represents no filter selected, not zero, because 0 in this case could return a value. We have values already put in there, so null just means that no restaurant has been selected. The first fetch, there are two use effect hooks. The first fetch, restaurants from API on mount stores the full list in the restaurant state variable. The second applies filters and has a dependency array containing selected rating, selected price, and restaurants. Selected rating, selected price, and selected restaurants. Whenever any of those three changes, the filter logic reruns. Inside that second use effect, a local variable called filter starts as a copy of the restaurant's array. The second applies filters and has a dependency array containing the selected rating, selected price. All right, inside the second use effect, a local variable called filter starts as a copy of the full restaurant's array. Then two conditional blocks run a sequence. The first checks to see if the selected rating is null. This strict not equal operator is used triple equals because we specifically want to distinguish null from zero. If the condition passes, the filter is called on the array. The callback receives each restaurant object R returns the Boolean expression r.rating is greater than or equal to selected rating. The greater than or equal to operator is correct here because selecting 3 stars shows the restaurant rated at 3, 4, or 5, not only exactly 3. It is a minimum threshold, not an exact match. The, the second block checks if selected price is not equal to null and uses pr.p price range triple equals selected price with triple equals. Here. This is an exact match because price range is a category $1, $2, or $3, not a minimum. Selecting a dollar would only show dollar restaurants, not dollar as well. After both blocks, set filtered is called with the result because both blocks run on the same local variable in sequence. They can both be active at once, rating the price filter together. Next, we're going to go over the cart rate and the stepper logic. All right, so next we're going to go over the cart state and stepper logic. The cart is a single state variable with TypeScript. Record, string, and number. This is a plain object where every key is a string, the menu item ID, and every value is a number, the quantity. It is declared with use state and the empty object as the initial value. When the menu loads, a loop runs over all fetched items and builds the initial cart object, setting every item ID to 0. Then it is passed to set cart. Sorry. Then it's passed to set cart with the functional update. The functional form passing a callback to set state rather than a value is used here because the new state depends on the previous state. The spread operator copies all existing key value pairs from previous into a new object. Then the computed property item ID overwrites just that one entry with mathmax.0. The handle quality change function takes 2 arguments, item ID and new quantity. Inside, set cart is called with the functional update. The functional form passing a callback to set state rather than a value is used here because new state depends on the previous state. The spread operator copies all existing key value pairs from previous into a new object. Then the computer property overwrites just that one entry with mathmax.0 new quantity. Mathmax takes 2 arguments and returns the larger one. Since the second argument is new quantity and the first is 0, the result can never go below 0. It is a mathematical error. The stepper components. Oh, wait a minute. Yeah, wait. It is a mathematical floor, not error. I'm sorry. The stepper component adds a second layer of protection. Function checks if value is greater than minimum before calling the decrement back to call it all. So the negative value is blocked at the UI level before it even reaches the handle quality change. The has items variable is derived using object.values cart sum quantity equal to quantity greater than 0. Object values return an array of numbers in the cart object. The sum method returns true if at least one element satisfies the callback condition. In this case, greater than 0. If every quantity is 0, sum returns false, has items is false, and the create order button receives disabled as true. All right, so that's my presentation for Module 13. Build a full stack food delivery app using React Native for the mobile client, Java Spring Boot for the REST API backend, implemented secure user authentication with JWT tokens and persistent session tokens with async storage. Developed a complete ordering flow, browse restaurants, filter by rating and price, build a cart, place orders in real time with confirmation feedback, created an order history system allowing customers to review past orders with few item breakdowns and status tracking, follow professional development practices, including Git branching, RESTful API design, and component based UI architecture and wireframe driven design.